In Washington, FBI ballistic experts establish positively...
For over 40 years, forensic chemistry has been used to try to find out whether a suspect has fired a gun. But the old simple methods have given way to a technique which goes into the invisible. As a gun is fired, it sends out a complex cocktail of chemical compounds and elements. Lead from the bullet, but also more unusual elements like barium and antimony from the propellant. For decades, forensic labs around the world have applied simple chemical tests developed in America. They test for the presence of these elements. A simple color change on the filter paper, or a change in the light spectrum from a flame. These were the telltale signs of the presence of each of the three key elements. But all the tests were for each element in turn.
They all suffered from the same fundamental limitation in that what they could tell you was that there were certain things present in a sample taken from somebody's hands, but they couldn't prove that that material came as a result of an association with the firing of a gun or whatever, because the materials, the substances which were being detected, lead and barium and things like that, are very common in the environment.
As a gun is fired, the heat energy vaporizes the lead, barium and antimony. There is only one place where all these three elements come together, near a gun. The surface of anything near gunfire, clothes, skin, hair, becomes covered with tiny particles. As the vapors cool, they condense and form small metal pellets. These are collected as part of normal forensic practice and would be tested for the three elements. But even if you found them all, each might have come from a different source. What you need is to show whether the three elements found in a sample really do originate from the same place at the same time. When it came, the answer was found using a common tool of the forensic scientists: the scanning electron microscope. This device allows the forensic scientist to see objects only a few microns across. The sample is locked into a vacuum chamber, and when inside, it's going to be inspected not with light, but with a beam of electrons. While using this for standard lab work, Robin Keeley hadn't realized it would be the tool which would offer up a solution to the problem of dealing with the original source of gun residues.
The solution came by chance. A colleague brought me some air filters which he'd collected on the laboratory firing range, and asked me to examine them for the presence of lead because they were worried about inhaling this lead when they were doing the test shots. And it was only when I started to look at the filters that I noticed these rather strange particles which I'd not seen before.
Scanning through the dust, he came across the mysterious tiny round particles. They came from a firing range, but were they from a gun? The electron microscope beam makes the particles give off X-rays. Attached to his microscope, Robin Keeley had an X-ray detector. Using this, he could see from the spectrum of rays which elements were present in the sphere: lead, barium, and antimony. A clear indication that the particle had originally come from a hot gun.
As different as guns and granites are, those last two stories were really about the same thing. Peering into the invisible and coming up with an answer to a problem that you really couldn't solve in any other way. Think of the power that analytical techniques like those give you and what you can do with them. You could identify the atmospheres of distant planets, check the balance of critical chemicals in the body, or even quantify the tiny traces of pollutants in rivers. The list is almost endless. Think on.